This will be for the con assignment, simplify square roots. So they want us to simplify the square root of 45. Okay, the best way to do that is just to write out the factors of the number 45. So I know that 45 is the same as 9 times 5. Okay, I can't break up the 5 any further. And I know that 9 is the same as 3 times 3. So you want to circle all of the last numbers at the end of the branches of the tree. Okay, and the square root of 45 is going to be the equivalent of the square root of those numbers multiplied by each other. So it's 3 times 3 times 5. All right, so anytime you see a number multiplied by itself, you can pull that outside of the square root symbol. So the square root of 3 times 3 is just 3, and we have the square root of 5 left underneath the radical symbol. So that's your answer right there, 3 radical 5. Okay, click the square root symbol right here and type 5. So here we have 450. Okay, we want to write out the factors for 450. I know that's going to be the same as 45 times 10. All right, it really doesn't matter where you start as long as you just keep breaking it down. 45 is the same as 9 times 5. And 9 is the same as 3 times 3. All right, the 5 we can't break up. 10 is the same as 5 times 2. All right, circle the last number in every branch. So we have 2 3s, a 5, and a 2. So the square root of 450 is equivalent to the square root of 3 times 3 and 5 times 5 and the 2. All right. Wherever you see two numbers multiplied, two of the same number multiplied by each other, you factor that, you pull that out of the square root symbol, the radical symbol. Okay, so since we have 3 times 3, the square root of 3 times 3 is just 3. The square root of 5 times 5 is just 5. So that's going to be multiplied by 3. And left over, underneath the radical symbol, we have the 2. Okay, and of course, 3 times 5 is just 15. And we still have radical 2. Okay, so the numbers that you pull outside of the square root, they get multiplied by each other. So click in the box, you type 15, click the square root symbol, and type 2. All right, we have the square root of 98 here. It doesn't really matter how you begin to factor, okay, as long as you get to the point where you get prime numbers that you can't factor. I see that 98 is an even number, so I'm just going to do 98 divided by 2, and that's 49. Okay, since 49 times 2 is 98. Can't break up the 2, that's a prime number. I know 49 is the same as 7 times 7, and I can't break up the 7s. So that's it. Circle the last number in each branch. So the square root of 98 is the equivalent of the square root of 2 times 7 times 7. All right, we can't take the square root of 2, but the square root of 7 times 7 is just 7. So you pull that outside of the radical symbol, and we still have radical 2 left over. So that's 7 radical 2. All right, last one, square root of 20. I know that 20 is the same as 4 times 5. Can't break up the 5. And 4 is the same as 2 times 2. So circle the last number at the end of each branch. And the square root of 20 is equivalent to square root of 2 times 2 times 5. Okay, and you can take the square root of any number that repeats. So the square root of 2 times 2 is just 2. And underneath the radical symbol, we still have the 5. So that's it, 2 radical 5. So just remember, if you take the square root of a number times itself, like if you have the square root of x times x, that just equals that number, x. All right. Any number multiplied by itself twice, you can pull that outside of the square root. So if you had x times x times x, the square root of x times x would just be x, and you would have the square root of 1x left over. All right, so just remember that. And the other thing I wanted to mention, you don't always have to factor each number all the way until you get prime numbers. For example, if we had the square root of 200, I know that's the same as the square root of 100 times 2. All right, and I know that the square root of 100 is just 10, and we still have a radical 2 left over. So you can do it that way as well. All right, you don't necessarily have to break up each number until you get to prime numbers, but you certainly can if you like.